Hey, yeah, great to be here, everyone. I'm Deli, co-founder of Automata. We're actually building verification protocols for trusted execution environment, or TEEs. Also, recently, it's been really helpful to have TEE as a foundational computation framework for AI models. It's getting more and more interesting because we've realized that when models are growing almost infinitely. The parameters are like billions, like hundreds of billions parameters out there. It's probably the most practical way is go with like TEs, and you will see some concrete examples, also like usage from industry as well. I think to start with, one thing I'd like to talk about is it's something that maybe you have thought about, why like current providers cannot be like fully trusted. There are actually quite a couple reasons. Maybe on top of mind right now is it's a black box. It's a black box because you don't really know like what kind of model is running there. Although provider is trying to tell you that we're running one of the specific model for you with some kind of a parameter set, but you can't really verify that. Another thing is there might be like performance degradations even during your like usage of the service. You can't really know, you can't really verify if your SLA is up to your standard as the standard. Also, at any point of time, maybe they could just slow you down in terms of the like token per second in their output. You can't really check those. And also, there will be like data concerns on like how they handle your data. I think most of the providers really provide options for things like maybe opt out of their analytics so that you don't really need to like they won't be like having your data, but it's not something that you can verify. So that's why I think it's important to recognize some of the issues. Maybe the first one is actually it's just the trust me bro issue where you can't really verify any claims from the providers. All the best you can do is just trust them or trust their, I don't know, terms of conditions or the privacy policies they have put on the website. It's very likely that some of them are already violating it. For example, you can't really know if they're training new models with your data. Even they said they won't be doing that. But you know, like in the model, you can't really directly see if your data is embedded. So there's no way, even in the future, to discover that your data was used for the model training. So this is becoming an issue. Second issue is actually the free lunch problem. I think people love LLM. Part of the reason is it's free. Most of the providers, also thanks to maybe DeepSeek, it's really pushed everyone now onto a freemium model. So you could just go to any of the providers' website and start immediately start chatting with the LLM, even without registering an account. But then the issue is it's kind of the same old issue that we have known like before, even at the Web 2 stage. I mean, like all the like internet companies are trying to harvest your data. I guess the more they can collect, the better they can build out their business model actually. So in the end, you're actually the launch to them essentially. So you're the product. Also, there's really lack of control in terms of how you could really opt out this kind of option or even switch off some of the settings. Maybe on the UI they have this settings, or maybe it's hidden somewhere. But the bottom line is you can't really know like whether they are really doing the way that they claim to do on the back end. And I believe in most of the providers' privacy policy, they will always have a term saying that for security reasons, we might keep your data for up to maybe 30 days to really like fight against like spams and other like fraud behaviors. But what if like something happened during that 30 days, then they somehow obtain your data and use for some kind of training? So, I mean, if you look, it sounds really scary. So it's not something that we can really understand and verify. So there has been really good achievement right now on like self-hosting your models. Also thanks to maybe DeepSeek's really good like development and open source of the model. Now you can run like all kinds of models across pretty much all the devices, ranging from your phones all the way to your laptop, or if you have a very beefy machine with the maybe NVIDIA GPU or even AMD GPU, you could really like spin up your own models, your own inference endpoint, and you could just rely on it. You don't really need any of the network, like internet-based models anymore. Of course, the upside is you have full control and also transparency because the data never leaves your device, it never leaves your network. But the downside is it might not be as good as those like cloud-based models, those proprietary models that from the OpenAI or cloud, Anthropic. Also, sometimes the setup is still painful, although there has been really good toolings to help you to do that. But still, it comes with some cost. Then actually also, I've been trying this kind of local like deploying models, like from like 7B all the way to 70B. Actually, if you are using a Mac device, Apple device, chances are they have, especially if you're using an Apple Silicon device, chances are you have enough memory to just run pretty nice models, maybe somewhere around 30B, or if you have really very beefy like Mac device, you can run up to 70B with no issue. There's really some trade-offs you have to think about. Also, if you, later on you will see that we have a live demo running a very small model, 1.5B model on your iPhone, on my iPhone. We will see that like how performant it will be. I'd like to actually talk about how to make the LM verifiable with some of the existing tags. There are actually quite a lot like primitives that we can use for this kind of verification purpose or solving some of the issues. Of course, like the bottom line is we can't really just trust like whatever claims that provided by the provider. It has to be verified objectively. So in terms of the integrity, you can verify, maybe use TEE because you have a really measurement of the environment. You can verify from bottom up. Also, you could use ZK if you manage to kind of convert the model into a kind of a ZK-friendly inference model. But again, the cost might be really high. Also, in terms of privacy, you could, again, just TEE to do the isolation because providers can't see anything inside the secure enclaves. It's also kind of the like how we can envision like in the future, like people are running this kind of cloud-based LLM for all the users. Also, maybe use FHE or MPC if you'd like to really compute over encrypted data. It also provides really nice guarantee because the operators can't really see any of the plain text because it got never sent to the like the operators. But again, there's trade-offs. I think TEs are available right now. There are also development on the hardwares, not only on CPU but also on GPU as well, to really make it more verifiable. Like maybe the other crypto primitives are still emerging. They're good, but maybe not as good as the hardware-based approach, given that we have really high demand on the LLMs. So maybe I'd like to give some quick overview of like TEs if you are like not familiar with it. So it's actually a hardware feature. It's kind of baked into most of the modern hardwares, including CPU and GPU. So these are all the brands that you can find the TEs in. Even your like Apple device all have secure enclaves. It's just that it's more proprietary. It's not that opened. And some of the nice features provided by TE is one of the things is the confidential execution, essentially isolated execution that nobody can see what's going on inside. Another thing is the integrity check because you can verify measurement that basically digest all the initial like setup of the entire computing environment. So later on, when you see this kind of measurement with a hash, with a signature, you will see, you can pretty much sure that someone is running this kind of, running the set environment for you. And also remote attestation is a big part because that's the only way for you to know that, something is right even without touching the actual physical hardwares. So with this kind of hardware approach, you could really go for a more hybrid approach. For example, you can combine the self-hosting model with a cloud-hosted model. So your own locally hosted model, actually you don't have to worry about anything on verifications or anything on privacy because it's owned by you. you're safe on using that. But when it comes to the remote models, I mean, there has to be a way for you to really understand whether they're running in a safe environment, running things on TEs. There's also various way of combining a local model with a remote model. You could just run a local model as a dispatcher. If it can't really answer the question, it can forward the request maybe to the remote one. It can also, the local run instance can also help you to verify the remote node, so that whenever it starts sending request, it always sends to the trusted node that has been verified. Actually, there has been industry adoption on this. So I think Apple just introduced this kind of private cloud compute just last year. They are actually running server-side secure enclaves using their own chip, Apple Silicon, and with a hardened OS, so that it pretty much is a pretty standard TE environment that runs only maybe a model inside. It has all the security setup, including secure boot, code signing to make sure people can verify it. Also to make sure their own device, like your phone, can also verify for you. Also, all the data is actually processed statelessly. That means they don't really store any data in this kind of node. Every time it serves a request, it will just once it's finished, it will just remove all the data from the memory, from the disk. So nothing sensitive will be stored on their node. Also, you could really trust that because you verified their attestation result. And also, because of the hardware feature, the enforcement, you don't really have to worry about the if they're collecting your data. Again, with this kind of setup, all the communication is actually happening between your device and the cloud using standard TLS connection. That literally means no one else can decipher the communication, the packets, except your device and that remote node. But the remote node again is trusted, so you're pretty safe in this case. This is actually one of the their architecture after combining private cloud compute with your locally run model, maybe on your mobile phone. I think they are doing some sort of smart routing so that when the local model feels that it's not able to handle the request, it will just connect to some of the previously provisioned private cloud node to finish the query and get back the result. Of course, there will be attestation report goes along with it that you can verify, but literally you are not verified because the device is doing that for you. There will be also transparency logs. Funny thing is, on their website, the way they describe this is it's an append-only ledger-like database. So it's literally, it feels like a blockchain, right? They're storing this kind of transparency log on a append-only log database so that people cannot modify it, can only see all the newly created transparency logs. So this is their approach on making the LLM verifiable. So over here, I'd like to also show that how you can maybe witness this kind of attestations, because Apple actually opened up the report functions to your local device so that you can really get the report that includes all the interactions between your local device and the cloud node. I actually already downloaded a report before, so I'd like to just show you over here what's included inside. So as you can see, actually it pretty much can include the original request I sent, and also immediately the local model actually decided to dispatch this to a remote node because it felt that maybe the local model is not powerful to handle the length of the text. Then you can see the second JSON squad structure actually contains the remote node that it connects to. It actually connects to a couple of them. Each of them have different identities, and each of them has a really important data field called attestation bundle. In the attestation bundle, it actually includes the things like attestation report and also part of the information that help you to verify this data structure against the transparency log that they published on their append-only database. let me see if I still have the one more command to really show you the each of the attestation bundle. This is actually the attestation bundle structure. So over here, it actually contains a lot of cryptags. So cryptags is actually one of the, you can think of it as plugins or programs they are loading when they spin up the secure enclave on the cloud. Although they are not really open sourcing their code, but at least they're giving out some of the hashes so that you can know that maybe some programs are actually running there. I mean, at least this is better than not revealing anything. And down there, you can see there's actually like some of the inclusion proofs here. I think on their website, they also mentioned that they're actually using Merkle proof structures to verify this thing efficiently. So every time they release new software for the entire, maybe the cloud environment, they will publish a new transparency log. They will also publish all the the proofs so that you can verify if each of the node is actually running the right software. Therefore, you can know they are not violating the route that they set up for you. So yeah, so this is the intelligence part. I mean, Apple intelligence part. Next part is actually the live demo running on my phone. We managed to, I mean, this is not something like really new. It's you can already try yourself. It's all open source code. So we managed to just load this kind of like 1.5B model on my phone. This is actually on my phone here, but I'm just showing you on the screen to just cast it over on my laptop. So this is a DeepSeek R1 distilled model with 1.5B parameters. And you can also tell from the icon here, this phone is actually on airplane mode, so it's not connecting to any of the networks. Then we go back to here. Maybe we just send a hi message. Yeah, it runs actually pretty fast. Maybe, I don't know, try something else. Like, you guys have anything you want to ask? Just throw me a... What's the best... Sorry, what's the best? Side event, okay. I think, first of all, I don't think it had knowledge of all the events here, so maybe I will just put it here and see how it will respond. Okay, it actually didn't return anything. I think this comes to a point that sometimes this kind of a small model can be retarded because it doesn't have enough information to really respond to it. But if you switch to at least 7B, chances are you can really get a meaningful answer. Or if you run this kind of thing, because I mean, Apple has a pretty universal like SDK. Same kind of app can also run on your MacBook. So on there, you can really have maybe 30B or even 70B models, which is quite powerful. And I mean, I've been using it. It's pretty okay to handle some of the really personalized requests because I'm not feeling comfortable sending those to OpenAI. Right, so let's see. I think we're running to the end, but there's still like last piece over here, which is how I think the industry like leaders are doing like this called confidential GPU right now. This is the like NVIDIA setup, how they're envisioning like, or how they're actually doing this kind of verifiable AI on their GPU. Essentially, they're creating a TE mode on their GPU card. In the most latest model, like H100, H200. So what it does is once the CC mode is on, so over here CC means confidential compute. So if it's off, then it's just a normal GPU, just like anything else. So it will just connect to maybe a normal like VM on the cloud. It would like do all the things that they could do before. But if it has CC on, that means they have TE enabled. What will happen is they will establish a channel between a already established like confidential VM, a TE. This is a CPU only one. It will establish a connection between that one with the actual card so that there will be an encrypted transfer channel. Then all the communication will go through this channel so that nobody can see your like model parameters or even see the actual inquiry. So if we really can run this kind of model, I mean, maybe a DeepSeek model inside one card, what will happen is the CPU, of course, will set up maybe a standard OpenAI compatible HTTP server, right, to serve the request. The CPU, I mean, the TE CPU will connect to will serve the request over TLS so that you have an end-to-end connections, which guarantee that nobody can see your inquiry. Then between the CPU and GPU, they will be going through the encrypted channel. They have also pretty standard, like, although I think they are using some of the existing encryption method, but it's probably not TLS. So in terms of efficiency, it's not that good. But still, it managed to protect all the data between CPU and GPU. So then now you really have an end-to-end kind of confidential LLM. Of course, if you have more cards, you could also have like multiple GPU attached to a single TE VM. You finish up all the attestations, you kind of lock up this kind of a linkage so that your user will always know that they are connecting to a node with a specific VM and maybe the other two specific cards that can be verified. And with this kind of setup, you can pretty much run some of the even more powerful models. I think as long as you can maybe get over 600 gigabytes VRAM, you can already run maybe a kind of full-fledged DeepSeek model without any compromise on the like parameter settings. Yep. So I think that would be everything for today. Thanks for having me here. I'm not sure if we have questions here. Yeah. Okay, then. Yeah, we're good. Yeah. Thank you.